My name is Christian Berg. I'm from Paliscope, and I have my colleague Mats with me here. We're not only colleagues, we're also very good friends since 25 years old, where we started at Chalmers, mostly drinking beer, to be honest. But now we're working together, and I hand it over to you.
Yeah. Thank you. Yeah, I started here in November. I've previously been at Foundation Chalmers Center, AstraZeneca, Record Future, and now here. So I do data stuff. Paliscope is a company with approximately 40 employees. Main office is in Stockholm and Gothenburg, but we also have in Denmark and the US. And what we do is supporting analysts and investigators for bringing out evidence from data. We have a lot of customers from law enforcement and the different governmental agencies. So this is a quote here. I don't know who said this. Maybe it's Christian.
Some other customers.
Yeah. So the problem isn't data. So you have a lot of data. You know, all the company says we need to be data-driven, and you pull in data. You use different tools for that, but then eventually you only have a set of Excel sheets basically, and with all that data, how do you make any sense out of that? So, and as well, you also have too much of it. So what we are doing, we do software for this. So YOS is the software that brings all these loose ends together, where it's basically a total dissemination of your data set. And data set then I don't mean one Excel sheet. It could be structured, unstructured data, anything, like a data dump from a computer, for example. You want to find everything that's in there for a police investigation, for example. And discovery, that's more of a tool for securing digital evidence and having audit log and so. But YOS is the dissemination tool. So you start with your data, anything. You know, what you have on your computer basically, it could be anything. From we say structured data, documents, HTML, PDFs, those are not really structured. You have to know, for example, CSV and Excel sheets, you have to know what the columns mean, right? But they're structured. When you know that, then they're structured. But then we have unstructured data, images, videos. Databases could be anything here that you just plug it in here. And then, of course, you have to tell the program what means what. But you don't have to tell it too much. Now we plug in a lot of machine learning and AI stuff. We extract the text and all the metadata around that, and doing all your, see these names here. Basically, those are all the tools that you typically find on blog posts, right? Object detection, speech to text, scene detection, license plate recognition. Some are more specialized than others, of course, and then of course NLP and translation. And this is not, now you have information from that data. Data is just a set of data points, right? Now we can start linking these together. So finding all the images with a certain person in, and what are co-occurring persons in this image, or in video frames, what are they talking about with speech to text? You can search this with text, so the video becomes searchable, as long as they have said something. But of course, we also have scene detection and object detection, so we can find all the frames with, for example, tanks or airplanes in them. Geoanalytics, time analytics, so you can find, for example, on forums, it's interesting to see when is the user active, because that might say something about the time zone, or if it's the same person as another person. Those things that get the investigator some kind of clues on how to move forward. So it's not automatic system that finds every connection afterwards. It's what you need is so you need to. The insights comes from the person sitting behind this and steering this investigation. So you have, for the tool is quite an advanced search and navigation space where you can navigate through all this data that you have collected and all the intelligence that you've got on. So putting all this together, we have these data, information, knowledge, and insights. You might have seen those words, and that's. We think that the most important thing is actually how to bring this together. So the last two columns, what we do, Of course, you have to have good extraction of information, but we're very flexible. In, if there's something new, we plug it in basically, and then we get more enhanced information on the right-hand side here. So here's just a potpourri of different things we do. Scene detection up on the left, object detection, OCR so in the wild, as I say, so things placed in the background, billboards and so forth, that can bring you clues on where this image has been taken, for example. If there's a sign, "Welcome to Baghdad," they might expect that this image is from Baghdad. And of course, OCR on ordinary documents as well. Face recognition, license plate and car brand recognition. And this is for police investigation purposes typically. So it's very closed sources. All these tools are fit into one computer as well. So these are customers are very closed sourcing. So there's nothing that leaks out here. I must say that as well. That also puts some requirements on what we can do. I'm going to talk later about language models, and we don't have large language models in our system because they have to fit on one computer. No cloud connection. You see here, there's an image there with 8 faces. That's from the Kick-Ass movie. We just did speech to text and then combined that with face recognition. Then you can see what faces were actually present at the time that phrase was said, which brings a lot of, can draw a lot of conclusions from that just by combining all these things. And of course, automatic transcription of for example, an interrogation movie here from the police that want to just give some support, being able to search through tons of interrogation movies. But the important thing is actually then on the right here, you see that with a link chart where you can find faces that have been found in other frames in a video sequence or in other images, and then you can draw conclusions and actually think about who knows who and who is connected to. For example, we had the Wagner Group investigation here on those faces on the left there. That's where we made a big open source intelligence extraction of information and dissemination of the Wagner Group. So this just a recap of this, where you have your ordinary text chats, you do parsing, you get the text out, but of course, bad guys sometimes write on notes. You want to find OCRs, you want to find what they write on the notes, and there might be text in videos or in images. So that's where you use OCR. And now we also get speech. Everything, all this becomes text. And text is nice, that's structure in a sense. We can do search, translation, and NLP, of course, to get entities out. And some clustering, I will talk about that later. So the chat clustering, last thing I'm going to talk about before Christian takes over again. So the use case here is, for example, if you have an investigation of a grooming or child abuse case so the police is investigating what has happened on this chat forum. And you want to identify the perpetrators, which is spelled wrong, and the victims on this site. So of course the police typically have an insight on who, one first person, this is the bad guy. But very often they use different personas. So they might have hundreds of different handles where they spam different persons on getting their attention. And you really need to find all this. So just having one, of course you probably get a case, but it's much stronger to say, we see that you have 10 or 100 handles, that you're just all over the place. So you have on the right here, you see that the ordinary link sharding, so to speak, that's where the police typically work with finding connection, who is talking to who and so. But we thought that just by looking at what they're talking about, how they talk, can we do that? And that's what we call chat clustering. We don't have a fancy large language model. Remember, this has to be fitted on one computer, no cloud connection. So we just thought of a simple way to do this using Word2Vec or Doc2Vec really. So just getting an embedding for every sentence that you have. You trained it specifically for this forum. So it's not generalizable. We don't expect it to be. So it's So unsupervised learning, so training just to get kind of grasp what the data looks like. And doing this on the chat forum here with 3,000 users, we found then the aliases of the groomer. So there's one red dot there which you probably cannot see, but that was the one that the police knew about. And then we saw that 10 different handles, they were speaking in the same way. And this is of course not foolproof to find all the things there, but it gets the police something more to start or continue digging. And you can also see some of the victims, they talk in another way. Some of the victims, they tag along a lot with these groomers. So they speak in a different way compared to a lot of the main bulk of data where they don't say anything or don't say much. It's also funny that we found these scammers. Those are the bots just generating messages. Where those are very specific, just automatically generated and just spamming people. So this is not the model that is supposed to be generalizable. We just train it on the data itself and plot it. Yeah, we do the same. This is just fun to just using what you can use Clip with. So Clip is a 2-year-old model, so it's ancient right now. But it's so powerful to, if you have hundreds of thousands of images, you have to get a grasp on what do we have. We create an embedding for each image. That embedding the model is trained with both text and the caption to that, or with the image and the caption to that image. So there is a connection with the language here, and also the content of the image. So by looking at this cloud here with TSNE, then you can see some of the clusters here, they are dark or black and white images. That's the cluster on the left here. All those are black and white images, and that's automatically then captured by this. And if you just scan over this with these thumbnails, then you can see, here are the tanks. Here are the black and white tanks. Here are the man-made disaster images. Here are the mugshots of militaries from the Second World War. And of course, that's a good way of sorting it out, but it's also good for image query and this with a photo of a royalty. Just ask that. You create an embedding from that sentence, and then that embedding is then searching for the closest images. So now I have to hand over to Christian.
You are fast, Mats.
15 minutes.
Yeah. So we use this, or not we, but our customers use this for quite a lot of things, and specific for use cases. And we do have quite a lot of sales compliance process. We don't sell this to the wrong entities. But in the top left, you have an image symbolizing trafficking. So we work a lot with organizations to scan for trafficking. And the problem there is they have too much data. So they, where they get the data from, that's from online, and they're just crawling a shitload of data, and they're stuck with it. They don't know what to do with it. And so that's where we come in place. Say, hey, we could probably help you. And there are so many things between these ads, because there's reality scraping ads. We're going to come back to the second one, but we work a lot with grooming cases and child abuse. Drug cases, of course, financial crimes and cybersecurity, and we do help a lot out in the war crimes area of the world, which is too close to us right now. And the general concept that all these use cases is that people lie all the time. No, you can't trust the criminals. This is, I might show the small picture of this. This is actually the Wagner Group. So we have been monitoring the Wagner Group through Telegram. Once again, way too much data really, and trying to figure out who they are. Who are they connected? Who are the leaders? Because these guys have been all over the world fighting wars. A lot of them dies on the way, but there are some living up, and they becomes the sergeant and commanders of the group. So we've been monitoring them and following all the links between them, and there were a little bit news of that last week. And we've been using quite a lot of different technologies to make those links. So there is a little video where we show a little bit about how we're working with image recognition in this sense. Let's see if it starts automatically or if it... right. So in this case, I'm choosing a logotype and searching for that one. And this is, of course, a fairly easy example as it's in the middle of the picture and it's very bright as well. But this is, of course, really interesting to follow certain tracks of a picture or certain pieces of a tank. So this is an example where we're searching for tanks. And here's another thing from an intelligence perspective. Why is it important to find that one? Well, that could be the scenario that someone is posting a picture on a tank in a Telegram forum, and they say, "Hey, we found this tank and this place in Ukraine." And the intelligence services, they like to know if, what kind of tank is it? Because if they know that the Russian has put in some old tanks at certain stage or a certain place, that means something for them, that they know they're out of the good tanks. And this way they can drew quite a lot of intelligence from all of that data. Here's another example how we can able to find a piece of that ad, really. This is in the subway in New York, I think it is. But these are the small little clues that we give to the intelligence and to search for. That could be pieces of a logotype, and especially in some scenarios there is a lot of visual intelligence. Going back to Matt's talk about the clustering. So here is it's a very tiny picture for you. I realize that, but this is a grooming forum. So this is a real data from a grooming case, and it's a similar one that Matt spoke about. And when the police get this, it's 3,000 people to investigate. Could take them a couple of years to do that process. But with this clustering technology, we're actually able to probably save them years of work, really. So once again, so it's a little bit of video. It's hard to speak and be photographed at the same time. So in this case, you have the bad guys, or the bad guy, to be honest. He's one. He's down there. And and these, when the police catch him, he said, "Well, I just did it once." Well, you have 5 aliases. You have not done it once. You've done it 55,000 times. Oh, no, that wasn't me. So the police has a problem here. They have to find the guys in the data set in the first place, and then they need to prove that it's him. And here we have all of the scammers on the left side. So those are easy just to filter out. We don't need to spend any time on those. And then when you see when I'm selecting here in the middle, you have the bad guys, really. So instead of working one by one, they can start to work with clusters of data. And this is a massive time saver. Otherwise, they need to start off with doing from A to B or A to, it's a very tiring process. But the police, in our case, they like link charts. They love it. That's the best thing. They love it to the heart. The problem is that you see how cluttered it becomes very quickly. And then also that's why we need to apply different technologies to make that understandable. I just need to. So we have 2 more examples. And this is once correlated really to war crimes, different data sets. It's Kick-Ass the movie. I've seen it many times now. In this case, we're looking for a sky to look at, because there is so much image data published online, and especially in Telegram forums. But most of the EXIF data is stripped, so there are no geolocations in them. And the first question is always, where has this been taken? So searching for skylines, for backgrounds, face recognition. You all seen those bounding boxes. So it's no difficult anymore. But it's hard to. There are not so many faces in the material because people know to hide themselves, but they don't know to hide the backgrounds. That's much harder. And by able to find clues like this, now this is a city, but that could also be a mountain chain in the background. And if you have multiple pictures of the same event, you can start to triangulate using this. It's simple. So you're trying to combine what AI can give us, combine it with the old traditional police work, really. Because in the end, the police needs to make this understandable for a jury, for the judge, for the lawyers, and they can't spell to ChatGPT. So there's a very big gap here between what's possible technically and what has to be presented in court and understandable by those people who think an iPhone is hard to operate. So this is a big challenge for us, and maybe mostly for our users, really. Finally, we are a fairly young company. We started a couple of years back, and when we started, we thought we were almost done. That was 4 years ago, and now, given Magnus' speech before, we can realize we haven't started yet, really. But we've made a video. How does our software work? And And now I can see it was more of a vision type of video. But I'm going to show it to you because there are two reasons. You can see how many different type of technologies can be used in an investigation. And also, I also would like to extract the hand here that we need new tech, and there are so many smart people in this room. So our strategy as a company is that we have to collaborate with everyone, really. And we try to find the best we can find in the world and put it into the hands of the guys who are going to serve us and protect us. So if you have an idea and you say, hey guys, I can do that much better than you, please just reach out because we love to collaborate with everyone. In the video here, it's actually a video of a real case. And being used in that one, you're going to see how face recognition being used. We have image matching, of course, chat, we have darkened data, a lot of geolocations, because in the end it's about finding the bad guy or finding the victim. That's sort of the end goal of it. And you can utilize all kinds of technologies to find there. So with that, I started. So with that we're ending our presentation. But it's when we speak to police forces, they have a big problem with too much data. It's insane, and the problem is they can't solve the cases because they don't have time for it. And it's a lot of data. They need to be accurate, and it's over a long time. And it's always all kinds of data. All of the spreadsheets, they're never the same, always different. And I think AI is going to be the key component to police forces to really solve more cases. So that is going to be absolutely critical. So talk to us, and thank you so much for today.
Thank you. Du står där borta så ställer jag frågan. So I mean, I love this case. It's so awesome that you can see that this technology can be used to for such an important question for society in general, I think. Do we have questions about this? So far, yeah, we have one there. Mic is on its way.
Thank you. Hi, folks. Really interesting. I mean, I'm no expert in this field, obviously, but I've often read and heard that people of certain minorities or backgrounds are disproportionately affected by police investigations or prosecuted. And I'm wondering, will AI, will that make that even worse, or can it improve it and make sure that it's a more even-handed justice system?
Very good question.
It's a good question, yeah. From our end, we come in the place when they have found the suspect, so in that after process. But of course, AI is going to be used a lot to find the suspect in the first place. And to be honest, I don't know. I mean, I think you're raising a question which is very important.
But I think in a sense, you lose some biasness in the way that you actually give the investigator more information. So the methods, of course, now we assume that the methods are unbiased, which we know, of course, that ML methods are typically biased in some sense. But anyway, you cannot close your eyes to that fact that you see more connections then they have to dig further, hopefully, instead of just, no, I believe it's that guy. Hopefully.
Probably AI explainability is super important to apply to these methods that you use to actually see if the model itself is biased.
Yeah.
Yeah.
And then in the end, of course, it's going to be a human person drawing the conclusion. It's going to be we have a justice system who's going to judge it in the end. But yeah, it's important, I think.
Do we have one question over there?
Thank you for a good presentation. I have a question regarding the clustering and whether there's something you could do across time. So I'm thinking things like you mentioned the clustering, you mentioned how people might die in combat, which would then, I guess, update the clusters and the information that you gather in clusters over time. So is there some sort of time series component to what you're looking at? I guess that could give more clues.
Yeah, well, especially when it comes, so we work a lot with the darknet analytics, and especially in that scenario, it's very interesting to combine old and new data, because if the forum closes down, they're going to be opening another one, and you can start to cross-match them. So there is that time component in a way to find, is this the same person across multiple forums, even if they have different aliases? And I think that is mostly why we've been using clustering and time in the combination. Not sure if that really answered the question, but
But there is, for all the data, there is a timeline on the top, basically, so you can find where the data points is, and then you can highlight. I only want to look at that point. So, and also when you saw that geoanalytic page, you of course saw how that person had traveled across the Golden Gate and back and forth, which was Christian in this case. But so of course that's pretty. There you also use the time. So definitely we can use it.